All right, page 461 today. We're going to talk about ratios and proportions. And a ratio is a comparison of two quantities. A ratio is a comparison of two quantities by division. The ratio of quantities A and B can be expressed the ratio of A to B can be expressed there's a bunch of different ways you can write a ratio. Okay, first and most common way is as a fraction. So the ratio of A to B can be written as the ratio of A to B. You can list it as A to B. A colon B means the same thing. All right, so those three ratios represent the ratio of A to B. When you're asked to write a ratio, or someone's describing a ratio to you, the first quantity given always gets listed in the numerator or first in the description. All right? What's listed first goes first. What's listed second goes in the denominator or goes second if you're writing the ratio horizontally. So an example there of the ratio of width to height okay, your width is going to go on the top and your height is going to go on the bottom. All right? Or if you're writing the ratio horizontally, your width would go first and your height would go second. So width to height or width to height. All right, so in that real world example number 1 right there, it says that a baseball player's batting average is the ratio of number of base hits to the number of at-bats. Minnesota Twins Joe Mauer led the batting average in Major League Baseball in 2006. He had 521 official at-bats and 181 hits. All right, so you were given 521 at-bats, 181 hits. All right, so you're going to divide the number of hits by the number of at-bats, because in the description it told you how to write the ratio for batting average. So his batting average would be figured by 181 over 521. And if you divide that out, that gives you 0.311. In baseball, they call that a 311 or a 311 batting average. If you can get 3 hits per every 10 at bats, or 300 hits, 311 hits for every 1,000 at bats in the major leagues, which is the highest level of baseball played on this planet, that would probably equate to about $8 to $10 million per year. Some professional team would pay you anywhere from $8 to $10 million per year if you could maintain that batting average at the major league level. So, yeah, you only got to get 3 hits out of every 10 at bats, right? Make 8 to 10 million. If you're a big home run hitter on top of that, you can make that more like 10 to 12 million. So, there's another example down on the bottom of that page. It said in Logan's High School there are 190 teachers. 190 teachers and 2,650 students. What is the approximate student-teacher ratio? So look, student-teacher ratio. They're asking for the student-to-teacher ratio. So your students are going to go in the numerator. Student-to-teacher ratio. Students go in the numerator. So we got 2,650. Students. Teachers, we got 190. And if we divide that out, we got 2,650 divided by 190. And that's about 14 to 1. So that can be written this way as well. 14 to 1. So about 14 students for every teacher. Here it's probably, I don't know what it is here. Feels like there's about 40 students for every 1 teacher, but I'm sure that's not the case. All right, bottom of page 461, extended ratios. Extended ratios can be used to compare 3 or more quantities. The expression A to B to C, A colon B colon C, is an extended ratio. And we've done some extended ratio problems this year. And the example on the top of page 462 should look a little bit familiar to you, so flip it over there. All right. The ratios of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. All right, if you're told that the ratio of the measures of the angles of a triangle are 3 to 4 to 5, the ratios of the measures of the angles in a triangle is 3 to 4 to 5. 3 to 4 to 5. Find the measures. Again, we did this earlier this year. If you got a triangle and you're told that the measures, or that the ratio of the measures is 3 to 4 to 5, okay? Hopefully you remember setting this up. We said that 3x plus 4x plus a 5x, the three angles have to sum 180. Alright, so this would be the expression that represents each angle measure. And they may not be to scale, but I just put a 3, the 4, and a 5 in each angle. So if you take your 3x plus your 4x plus your 5x, they all have to add up to 180 because we're dealing with a triangle. So in order to find the measures, we can solve for x. So we got 12x equals 180. Can divide each side by 12. Our x is equal to 15. Alright, if the x equals 15, we can go back and substitute. So we got a 3 times 15 right here. So this angle's 45. We've got a 4 times 15. So that angle's 60. And then a 5 times 15. And that's a 75-degree angle. So there's how you would use an extended ratio to find the measures of a triangle. You can also use it to find the lengths of the side of a triangle if you're given the perimeter. So let's look at the example on the guided practice right down there on the bottom of that, in the bottom of that box. It says that in a triangle, the ratio of the measure of sides is 2 to 2 to 3. Perimeter is 392. Find each side. Find each side length. Alright, so we're dealing with side lengths now. So if we got a triangle, one side is going to be 2 times a number. The other side will be 2 times a number. And the third side will be 3 times a number. Now you're told in the problem that the perimeter is 392. Perimeter represents the sum of the sides. So we got a 2x plus a 2x plus a 3x that has to equal 392. Alright, so 7x equals 392. Can divide both sides by 7. And we get 392 divided by 7. So our x in this case equals 56. That's your multiplier. So these two congruent sides are going to be 2 times 56, which is 112. And this third side will be 3 times 56. And that's equal to 168. All right, so you've got a 112, a 112, and a 168. All right, so any questions on writing ratios or using extended ratios to find side lengths or angle measures in triangles? All right, with that, we're on kind of a modified schedule today because of something that's going on during your fourth period class. So your assignment is going to be page 464. One through 4. And then continue that into the next page. And then let's do 10 through 12. Actually, just do 10 through 20. 10 through 20. There we go.